are busy with question paper B1 and we are still doing question number 5. In fact, we just started question number 5. So question number 5 is a given function that says it's minus 6 divided by x over minus 3 minus 1. Now you can see that format, and let's just start on a new page. What does that format tell us? If I have a function a over x minus p plus q, there's a few things we know about this function if it is f of x, right? So, I'm sorry, it's near 4 a.m., so I'm trying really hard to concentrate here. Firstly, we've got asymptotes, right? The asymptotes are x equals p, that is the vertical asymptote, and vertical is a line up and down like that. But I'm just going to take that out, because the vertical is an up and down line that goes like so, right? Then you get a horizontal asymptote, which is like so, and the horizontal asymptote has equation we really have to work on this handwriting. Let's just try and improve on it. Horizontal asymptote is going to be y is equal to q, which goes across like so. So those are the asymptotes, 1 and 2. I'm just going to list that as 1 there. Secondly, the type of graph this is a hyperbola. This is a hyperbola, and this graph looks like so and like so. Okay, make that number 1. Make the asymptotes the second property that we know of it, and I think that's about it. That's all you really need to plot the graph as. I mean, that makes it specific to the hyperbola. There are of course the general things like the x-intercepts and the y-intercepts, but that's general, right? Because how do you find the y-intercept? Is you make x naught, make x equal to 0, and then solve for y. And how do you find the x-intercept? Is you make y equals 0, and you solve for x. So those are two things that you see over there quite often. So let's use a real example. Let's say I've got f of x is equal to 3 over x minus 4 plus 6. The horizontal asymptote from here will be y equals 6. That's a y. That's a y. There we go. That's y. And the vertical asymptote will be x is equal to positive 4. Right, because the sign swaps, and for the y that stays the same. Now how do you find the, so we got the asymptotes, how do we find the x-intercept and the y-intercept? Well, if you want the x-intercept, you're just going to make y 0, but let's start with the y-intercept because that's easy. You make x 0. Okay, so I'm just going to put over there y-intercept, make x 0, then we will say y is equal to 3 over negative 4 plus 6. That's because I made the x 0, and that is going to be 3 over 4, sorry, it's 6 plus negative 3 over 4, which is just going to be 5 and 1/4. And 5 and 1/4 is going to be 5 times 4 is 20 plus 1, 21 over 4. Okay, which is 5 and 1/4. Okay, and then the x-intercept, similarly, you make y 0. So we're going to say 0 equals 3 over x minus 4 plus 6. And I think you can do a little bit of solving there, and then you'll get positive 6 on this side. X minus 4, you'll get the following. You'll get x minus 4 is equal to, bring the 6 below, it's going to be minus a half, and then you're going to just take that over. You're going to get 4 minus a half. X is equal to 3.5. Okay, I'm writing in the very corner of the trackpad here. Okay, and then of course you want to plot that, and then so this is in essence what we're talking. We're saying it's a hyperbola. It's got a vertical asymptote. It's got a horizontal asymptote, and then an x-intercept and a y-intercept, and that's really everything there is to the hyperbolic function. So I'm going to go back to the previous page, and then we are going to continue with our question over here. So let's start. Let's start with our asymptotes, right? I'm going to just put it on as 1. Let's start with our asymptotes. What do we know about our asymptotes? Firstly, the vertical asymptote is going to be the one with the x equals 3 is one of them. And then the horizontal asymptote, I'm going to put v there. The horizontal asymptote is going to be y equals -1. So let us immediately start getting some of these out of the way here. There's our axes, and I'm going to use a blue color for the asymptotes. Is there a way to... No, there's no way to get a... I'm going to use a blue color for the asymptotes. I'll just make them a lot longer. Vertical asymptote will be at +3. And the horizontal asymptote will be at -1. I just made them a little bit longer. Those are our asymptotes, right? And we can use a red color to get a +3 in there and a -1 there. So the green is our axes, and I'm just going to use green with a thick pen to indicate what the axes are. The x and the y axis, I'll put it over there. That's my y, and this here is my x-axis, right? So that's the two asymptotes that we've got, and we've got the vertical asymptote, which is at 3, the horizontal asymptote, which is at -1. And later when we start drawing the graph again, I'm going to start using a blue line. Okay, so I'm going to stick to red for the calculations for now. Okay, so there's our two asymptotes. Now that's about it. Number 2, we're going to start looking at the the y-intercept. Is where we make x equal to 0. So remember, this here refers to our y. F of x is our y. So I'm going to make that equal to x equals 0. So I'm going to say y is equal to -6 over 0 minus 3 minus 1. So -6 over -3 is going to give us +2 minus 1, and 2 minus 1 is just 1. Similarly, we're going to say x-intercept. So the y-intercept is going to be at +1, which is round about there. Say that's 1. I'm using a very, very thin pen. That's +1. That's my y-intercept. And my x-intercept is going to be somewhere, going to make y equal to 0. And then I'm going to get -6 over x minus 3 minus 1. I'm going to take this -1 to the other side. In other words, I'm going to add +1 to both sides. Then I'm going to get is equal to -6 over x minus 3. If I continue, and I continue working this out over here, I'll get 1 multiplied by x minus 3, because I'm multiplying both sides by x minus 3, is equal to -6, which is simply x minus 3 equals -6. Therefore, x is equal to -3. Right? So x-intercept, if that is 1, that's 1, 2, 3. That's my -3 over there. And let's draw the graph. So it's going to be in the opposite two quadrants over here. I'm going to join it like so. It's hyperbola. Okay, that looks a little bit rough. It may not be 100% accurate because my axes may have some trouble, but that's the hyperbola we have. And then this quadrant over here, that's what it should be looking like. Okay, so that, in fact, I answered all the questions right now. I just answered question 5.1.1, where they ask you for the y-intercept and they want it as a coordinate. So the y-intercept as a coordinate is going to be 0 on the x, +1 on the y. This is question 5.1.1. Right? And this question over here, the x-intercept, they want it also as a coordinate, so it's going to be 0 on the y, and it's going to be -3 on the x, like so. And this was question 5.1.2. Right? And then they asked for 5.1.3 as well. We did it all in one, where they ask you to sketch the graph. Okay, now comes the next question. They want to know for which values of x is f of x greater than 0. Where is this graph positive? Well, over here the graph is negative. and anything under this line on this side, the graph is negative. So when x is bigger than -3, so I'm going to just put it over here, 5.1.4 for x greater than, and do they want equal to? Let me just double check. Do they ask you if it's equal to? No, just greater than 0. It's positive. The y value is positive from here onwards. So it's just greater than -3. And that should be it. X is an element of the reals. Okay. Okay, so as you can see, it must be greater than -3, but at the same time, it must be less than this 3, because when you extend, for example, when you extend this line, this asymptote, you know the asymptote continues, right? It doesn't stop there. Then you know that this graph, the graph goes on, but it never touches. With an asymptote, it can get close to, but it cannot touch. In other words, you can approach, but you cannot touch. Approach, but do not touch. Okay? And that's exactly what happens with this asymptote over here. It goes up and continues on, but it must be less than 3. So it's not just more than -3, it is also less than +3. And we can combine that. We can combine that. So I'm going to erase this quickly, because for space I'm going to erase it, and I'm going to put on there x must be less than the +3 that you see on this side, and greater than the -3. Okay, there we go. So we did 5.1.1, 5.1.2, we understood the asymptotes because we had to write it down and draw them, and then we drew the graph, and we also answered question 5.1.4.